Okay, ladies and gentlemen, let's take a very quick look at some triangle inequalities. Now, before we talk about triangle inequalities, let's talk about inequalities in general. First of all, if A is less than B, don't know what A is, don't know what B is, but I do know that I am given that A is less than B. Well, if A is less than B, if I add something C to A and I add something C to B, then A plus C is still going to be less than B plus C, because if I add the same amount to both sides and one was less to begin with, it's still going to be less if you added the same amount to both sides. So that would be the addition property of inequality. Now the same thing would happen as if I said A is less than B and I subtract the same value from both sides. That means A minus C is still going to be less than B minus C, because again, I did the same thing to both sides. As long as I do the same thing to both sides, they're going to stay the same. Now, obviously, the only thing that changes this is the same thing that changes greater than or less than otherwise. If I multiply by a negative number, if I divide by a negative number, then what was less and what was greater have to switch, which is why we switch the signs in algebra when we multiply or divide by a negative. But that's the addition property, that's the subtraction property. There is the other one, which is the transitive property. Transitive property says if A is less than B and B is less than C, then not shocking, A has to be less than C, because if A is smaller than B, but B is smaller than C, A has to be smaller than C. So if and then. If this is true and this is true, then that is true. Not that terribly shocking. Now, let's do something a bit more interesting. In any given triangle, we can talk about side lengths. Now, to me, this one looks to be the longest side. This one looks to me to be the shortest side. And this looks to be the medium side. Okay, if that is the case, the inequalities of triangles theorem says that the longest side is always across from the largest angle, and the shortest side is across from the smallest angle, and the middle side is going to be across from the middle angle. In practice, it works like this. If I have something like this, 8.2, 9.1, 3 point, well, that looks way longer than 3. Let's go 6.8. If that's the case, A, B, C, if I'm listing these angles from largest to smallest, then this angle on this side go together, this angle on this side go together, and this angle on this side go together. So from largest to smallest, it's going to be angle B is the biggest, then angle C, then is greater than angle A. So angle B is greater than angle C is greater than angle A. And you put them in order. Now, it works the same in reverse, by the way, too. If I have, say, 79 degrees, and over here I have 40 degrees, that would be 119, 119. 119 would leave 51 to 59, 119, yeah, 51 degrees. All right, if that were the case, which is the longest side? This is going to be the longest. This is going to be the middle. This is going to be the shortest side. So we can put them in order by greatest to smallest based on angles and sides. Now, that's not the only thing we can do. In any given triangle, it says that any exterior angle, so this angle out here on the outside, is going to be greater. So angle 1 is greater than, and we'll call this 2, 3, and 4. It's greater than either of the two remote interior angles, greater than angle 3 or angle 4. Now, here's the reason for that. We already know that if we have an exterior angle, the exterior angle theorem says angle 1 equals angle 3 plus angle 4. And we know that because the triangle has to add up to 180, and these two angles have to add up to 180. So this one has to equal those two put together. Well, if I take this angle, it's got to be bigger than this one, and it's got to be bigger than this one because these two together make that outside angle. So if I were to make this, say this is 120, that would make this 60. Now I don't know what these two are, but together they have to add to 120. So if 1 is 120, and that equals 3 plus 4, and 3 plus 4 equals 120, any one of these by themselves has to be smaller than 120. And it works on every single one. This angle here has to be bigger than this one or this one. This angle over here has to be bigger than this one or this one. It applies to any exterior angle. Now, obviously the biggest exterior angle is going to be outside or exterior of the smallest angle of the triangle, because the smallest angle of the triangle would be supplementary to the biggest angle of the triangle. So, a couple things to kind of warp your brain there a little bit. And the thing to remember is that when we start putting this together with isosceles and equilateral, it becomes important because now you know certain things are congruent to each other, and you can begin finding pieces of the puzzle. So that is triangle inequalities.